Hi viewers, in the physics reflection of light, class 10, ray diagrams for convex mirror. Rays of ray diagrams for convex mirror. In the previous video I explained concave. Now this is convex. Of two positions, rays are divergent. We know convex mirror, two cases, object is placed at infinity, object is placed between infinity and pole. So first one I am explaining, object is placed at infinity. Taking the measurement, the scale, exact values I will take. So I'm drawing a line segment of 8 centimeters, half of, so at 4 and 8, that is C and this is F. You know that R equal to 2F, that is twice the focal length is radius of curvature. So I'll draw the arc, convex mirror surface. This is the arc. We know that this will be curved outwards. Convex mirrors are curved outwards. Focal length and center of curvature will be behind the mirror. So this is curved outwards. Convex mirrors are curved outwards. Concave are curved inwards. Now I'll place an object. I'll try to extend this principal axis line and darkening this one. This is the principal axis. So I'm placing the object of 2 centimeters size. So how to draw the ray diagram now? Observe. So this is AB, object, so I placed at infinity position. Now we will draw, this is pole. Now this is pole, this is focus, then that line is principal axis. In the previous video I already explained this terminology. So this is principal axis. Now I'll draw the horizontal line from the top of the object onto the pole. I'll draw a horizontal line exactly straight, that means parallel to the principal axis. The reflecting ray will be divergent from focus. So this is the reflection ray, represented with dotted inside the mirror. So that is the reflected ray from focus. Incident, this is incident, then reflected from pole. That is always from the focus. Now the same way we'll do same down the principal axis. So horizontal line parallel to the principal axis onto the pole. So incident, again this will be reflected. So this is reflected ray, represented with dotted lines inside the mirror. This is reflected. So now the image formation is at focus. Image formation is at focus. So now the nature of the image will be virtual image. Why? Because this is behind the mirror. So this is virtual image. And if you observe, this is highly diminished, very small, like a point size. So highly diminished point size. And this is at focus, at where the object image is found is at F. So infinity position I explained. Now coming to object is placed between infinity and pole. The same way I drawn, the same measurements, 8 centimeters. So infinity and pole. Object is placed at infinity and pole. I'll extend this principal axis line to the left hand side. Pole. So with 1 centimeter size, placing the object AB. I'll darken this one. Object size I have taken 1 centimeter, that is AB. Object. Now from the top of the object we'll draw a parallel ray onto the pole. Incidence, reflection will be from focus. So this side dark and inside we'll draw with the dotted lines. For the convex mirror, these are the divergent, so diverges from focus. And from the top to the center of the curvature, incidence. So with the dotted lines we'll mention up to the center of curvature. Incidence, that is reflected. This is incidence form. So where these two rays are intersected behind the mirror with the dotted lines, there the image will form. So here this is the image formation represented with A dash B dash. Image. This intersection gives A dash B dash. So this is A B object and this one is image. Now nature. This is virtual image. We know behind the mirror is virtual image. Behind mirror, that's why it is virtual image. This is erect, not inverted. This is erect. Image is erect and this is diminished, somewhat diminished. You can observe clearly the size of the object and image is somewhat diminished. And this is image formation is between pole and F. Between pole and F. This is the explanation. I hope you understood.